NCERT.com Science 7. Chapter 7. Heat Transfer in Nature.
Heat transfer. Heat transfer is the movement of thermal energy from a warmer object to a cooler one until they reach equilibrium. This process is essential for everyday tasks like cooking and heating. There are three primary mechanisms. Conduction. Heat moves through direct contact, such as a spoon warming in hot tea. Convection. Energy circulates through moving fluids, liquids or gases, like rising steam. Radiation. Heat travels via invisible waves, allowing the sun to warm Earth through space. Conduction of heat. Conduction is the transfer of thermal energy between objects in direct contact or within a single body, moving from the hotter end to the colder end. This flow continues until thermal equilibrium is reached and temperatures equalize. Key conditions. Direct contact. Objects must touch. Example: a flame and a metal rod. Temperature gradient. Heat only flows if there is a temperature difference. How it works. In solids, molecules are tightly packed. When heated, molecules at the hot end vibrate rapidly, passing energy to neighboring molecules through successive collisions. This chain reaction effectively transports heat through the material without the molecules themselves moving to a new location. Good and poor conductors. Materials are classified by how quickly they transfer heat. Good conductors, primarily metals like copper, aluminum, and silver, allow rapid heat flow, making them ideal for cookware and engines. Conversely, poor conductors, insulators, like wood, plastic, and rubber resist heat flow. These are used for handles and containers to keep food warm and protect our hands. Common uses: copper, silver. Rapid heating for high-end pans and tools. Aluminum, lightweight heat distribution in cars and kitchens. Stainless steel, even cooking and durability. Uses of insulators. Uses of insulators. Insulators, poor conductors, are essential for safety in temperature control by resisting heat flow. Key applications: construction, materials like brick, mud, and asbestos keep buildings cool by blocking external heat. Safety, insulating covers prevent flammable substances, like petrol, from overheating. Handles, wood, ebonite, or plastic handles on cookware protect hands from burns. Clothing, nature, fur, wool, and leather trap body heat, keeping humans and animals warm in winter. Convection of heat. Convection is the heat transfer process where warmer parts of a fluid, liquid, or gas move to cooler surroundings. Unlike solids, fluid molecules can move freely, creating convection currents as heated, less dense material rises and cooler material sinks. Practical applications: ventilation, hot, exhaled air rises and exits through high ventilators, replaced by fresh air from windows. Heating, central heating systems circulate warmed water or oil through pipes. Thermos flasks, designed to minimize these currents to maintain temperature. Heat transfer by radiation. Radiation is the fastest mode of heat transfer because it doesn't require a material medium, allowing it to travel through the vacuum of space at the speed of light. Unlike conduction or convection, heat is transferred directly from a hot body to a cold one via electromagnetic waves. Key characteristics: source: all hot objects emit radiant energy. Distance: the intensity of heat received decreases as the distance from the source increases. Absorption: a body's ability to absorb radiant heat depends significantly on its color. Ultimately, radiation explains why we feel the sun's warmth despite the vast vacuum between us. Applications of radiation. Clothing: light-colored clothes are preferred in summer to reflect heat, while dark clothes in winter absorb it to keep us warm. Heaters or utensils. Room heaters use polished surfaces to reflect heat, whereas cooking utensils and solar cookers have black bottoms to maximize heat absorption. Engineering. Car radiators are painted black for efficient cooling through radiation. Thermos flasks, sealed with glass surfaces, minimize heat loss by reflecting radiation back. Energy. Solar cells capture radiated energy from the sun. Heat in the water cycle. Solar energy is the primary engine of the water cycle, driving the transformation of water between its three states: solid, ice, snow; liquid, oceans, rivers; and gas, vapor. Key processes. Evaporation. Heat speeds up the conversion of liquid water into rising vapor from oceans and wet surfaces. Atmospheric change. Vapor forms clouds, eventually returning as rain. Seasonal shifts. Sunlight melts glaciers in summer to feed rivers, while winter snow restores frozen reserves. The water cycle. The water cycle is the continuous movement of water between Earth and the atmosphere, driven by solar energy. 4 key stages. Evapotranspiration. Heat turns liquid water into vapor from bodies of water and plant leaves. Condensation. Vapor cools at the dew point, forming cloud droplets around dust particles. Precipitation. Gravity pulls moisture down as rain, snow, or hail depending on temperature. Infiltration. Water soaks into the ground, replenishing aquifers and sustaining life. Infiltration and aquifers. Infiltration is the process where rainwater disappears by soaking into the earth through soil gaps and rock cracks. This water moves downward to become groundwater. Key concepts. Aquifers, underground layers of porous rock, sand, or gravel that act like sponges to store water. Extraction. People access these vital reserves via wells and boreholes for drinking and farming. Sustainability. Because aquifers refill slowly, careful management is essential to prevent depletion. Effects of excessive groundwater extraction. Over-extracting groundwater disrupts the water cycle, leading to severe environmental and structural consequences. When aquifers aren't allowed to refill, the natural balance is lost. Key consequences: dry wells. Water tables drop, causing boreholes and wells to fail. Land subsidence. The ground may sink, damaging buildings, roads, and infrastructure. Contamination. Overpumping can pull in saltwater or pollutants, ruining freshwater supplies. Habitat loss. Wetlands and springs shrink, threatening the plants and animals that depend on them. Water conservation. Despite the continuous water cycle, conservation is vital because most of Earth's water is saline and unusable for drinking or farming. Growing populations and industrialization have further strained our limited freshwater supplies. Water conservation is the wise and careful management of this resource. Strategies for conservation. Prevention. Treat sewage and industrial waste to avoid pollution. Repair leaks promptly. Daily habits. Turn off taps while brushing and water plants during cooler hours to minimize evaporation. Infrastructure. Build dams to manage floods and store water for irrigation or electricity. Innovative solutions. Implement rainwater harvesting, increase green spaces for groundwater recharge, and use ice stoppers to store winter water for summer use.